Hello, welcome to the Home of Science. Subscribe to the channel as you watch the video and invite more of your friends to watch these exciting videos. Okay, I want us today to discuss how to write chemical formulas in chemistry. This is one difficult thing in chemistry that learners find very difficult to write chemical formulas. Okay, so what is the first thing that you need to know or learn in order for you to be able to write those chemical formulas? The most important thing that you need to learn, you need to learn valence. Okay, so we'll discuss valence, then we'll go to writing of chemical formulas. So I was saying learners find it very difficult to write chemical formulas. For example, if they say write the chemical formula of sodium chloride. Okay, so sodium chloride, to some of us, me as a teacher, I know how to write sodium chloride. It is NaCl. But where is this NaCl coming from? Okay, they can also maybe say write sodium carbonate. Okay, then I'll say Na2CO3. Okay, so here Na, I did not write a 2 here, but why have I written a 2 there? So that's the reason why we want to discuss valence, to understand why we have a 2 here for Na when there we do not have a 2 for Na. Okay, so like I was saying, the first thing you need to know is valence. Okay, so we'll discuss valence. Okay, what is valence? Okay, valence is defined as the combining power or capacity of an element. So you're saying the combining okay, valence, the combining power or capacity of an element. Okay, the other definition for valence, which makes it very simple to understand what we mean by valence. Okay, so valence, we say it is the number of electrons that should be lost, gained, or shared in order for an element to gain stability. So valence is the number of electrons which should be lost, gained, or shared in order for an element to gain stability, in order for an atom to gain stability. Okay, so we are saying the number of electrons lost, gained, or shared in order for an atom to gain stability, or just in order for an atom to be stable, so that an atom should have a stable electron structure. So with the exception of lithium, hydrogen, and beryllium, all other atoms should have 8 electrons in the outermost shell. So when they have 8 electrons in the outermost shell, that's what we are calling stability, meaning they have gained stability, they are stable. So we are saying valence, the number of electrons lost, gained, or shared in order for an atom to gain stability. Okay, let's move on. So how do we determine the valence? So the easiest way to determine the valence, we use the periodic table. So the easiest way to determine the valence, we use the periodic table, with the exception of transition methods that is on the periodic table. So how do we use the periodic table to determine valence? So we do this. Here is the simple table that you can be using. for you to be able to determine the valence of an element, provided you know the group on the periodic table that element is coming from. Okay, so here is just a table. Then on top here I'll write group, meaning the group of an element in that periodic table. Then down here I'll have valence. Okay, then I'll have all the groups on the periodic table. So you have group 1, okay, 2, 3, 4, 5, 6, 7. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we have 8 groups on the periodic table. So we have group 1, group 2, group 3, group 4, group 5, group 6, group 7, and group 8. Okay, so this is what we do. All the elements which are in group 1, they have the valence which is 1. All the elements which are in group 2, they have a valence which is 2. All the elements which are in group 3 have a valence which is 3. All the elements which are in group 4 have a valence which is 4. Okay, now here it changes. It is dropping now. So the middle number is 4. Then it should start dropping this side. So all the elements which are in group 5, so dropping from 4 meaning we are going to 3. So all the elements in group 5 have the valence 3. All the elements in group 6 have the valence 2. It is dropping. All the elements in group 7 have a valence 1. And all the elements in group 8, they have a valence 0. So usually the elements in group 8, their valences are not even required. So we only deal with the elements which are in group 1 up to group 7. So here is the pattern. If you start from group 1 going towards group 4, you also start from group 7 going towards group 4. We see that there is a pattern there. We are saying group 1, valence 1, group 7, valence 1, group 2, valence 2, group 6, valence 2, group 3, valence 3, group 5, valence 3, and group 4, where they are meeting, the valence there, it is 4. Okay, so the pattern goes like this: valence 1, valence 1, valence 2, valence 2, valence 3, valence 3, and then valence 4. So that is how a pattern goes, with the exclusion of group 8 here. So we know group 8 elements, they have a valence of what? They have a valence of 0. So we can even remove them there. Then we can only have group 1 up to group 7. So that's the pattern: valence 1, valence 1, valence 1, valence 2, valence 2, valence 3, valence 3, and the valence 4 on the middle there for group 4. Okay, now let's go to writing of formulas. So once you know this, it will be very easy for you to write a chemical formula for a chemical formula where a radical is not involved. So for the radicals, I'll also make a video, which will be the next video, where I'll show you how to write formulas when a radical is involved there in a chemical formula. Okay, so a question here. Okay, a question, which is question 1. So a question, write down the chemical formula of the following. So A, start with sodium chloride. B, go to sodium oxide. C will go to, you can write magnesium fluoride. Mg, we can have aluminium oxide, and okay, I think from what we have here, somebody can learn how to write the chemical formulas. Let me put one more, E. Okay, we can have calcium. We can have calcium sulfide. Okay, solutions. Okay, here are the solutions. So we write down the chemical formulae of the following: sodium chloride, sodium oxide, magnesium fluoride, aluminium oxide, calcium sulfide. Okay, let's go about it. So this is what we are going to do. Number one, we know we have sodium chloride. First thing, you identify the elements in a given compound. So that is the first thing. So which are the elements in this compound? The elements, it is in sodium. There is also chlorine. So chloride here, it is the chlorine which has changed the name now to chloride, which means it is an ion of chlorine. Okay. So the first thing, like I was saying, you identify the symbol. So the symbol for sodium, it is Na. Okay. So Na, in which group do we have sodium? So sodium is in group 1. So those elements which are in group 1, their valence is 1. Okay. You can check on your periodic table there. Sodium is in group 1. Okay, so we write the valence on top like that. Then we also write the symbol for chloride, which is chlorine. So the symbol for chlorine, it is Cl. In which group do we have chlorine? Chlorine, it is in group 7. And we know the elements in group 7 have a valence 1. Okay, so we have a valence 1 there. Then the valences, they'll interchange. You interchange the valences, meaning sodium will go with the valence of chlorine, and then chlorine will go with the valence of sodium. Do not interchange the symbols, only interchange the valences. Okay, so we have Na, we maintain our Na, it is now going with the valence of chlorine, which is 1. And now that one, as they interchange, it will drop down here. It will be there. Okay, then we also have Cl, which will go with the valence of sodium, which is 1. Okay, now when you have A1 in a chemical formula, A1 must be invisible. You shouldn't show that there is A1 there. Okay, so what do we mean? This one should disappear. It should be invisible. So Na is more like we have one of sodium atom, which is the same. No wonder I was saying it should do. You should not show it. It should be invisible. Then we also have Cl with the one there, also an invisible one. Then what we have here is the formula for sodium chloride. Okay, let's go to B. B, we have sodium oxide. Sodium oxide. Okay, so we also identify the elements in a given formula there. So which are the elements in this given formula? So we have sodium and we have oxygen, giving us the name oxide. Okay, so the word oxide is coming from the word oxygen. So we need to write the symbol for oxygen. Okay, so the symbol for sodium, Na. The valence for sodium, we said it is in group 1. So the valence is 1. Okay. Then we also have the symbol for oxygen, which is O, giving us oxide. What is the valence of oxygen? Okay, so in which group do we have oxygen? Oxygen is in group 6. If you check on your periodic table there, it is in group 6. And the elements which are in group 6, they have a valence which is 2. Okay. So I have a 2 on top there, which is the valence of oxygen. Okay, what do we do next now? The valences, they will interchange. Okay, like that. More like cross multiplication, showing that the valences there, they are interchanging. Okay, but we maintain the elements. Okay, so this side we have Na. Now this Na will go with the valence of oxygen, which is 2. Okay, so I have a 2 here. Then that 2, as it comes here, we need to drop it down and not we shouldn't write it on the top. Okay, so we have a 2 there. Then we also have oxygen, which will go with the valence of sodium, which is 1 there. So we have a 1 here. Remember, on the first example, which is example A, I said when we have a 1 in a chemical formula, that 1 should disappear. Okay, so we have Na2 and A1 there, which is disappearing. So what we have here, Na2O, is the chemical formula of sodium oxide. Okay, next, C. C, we have magnesium fluoride. Magnesium fluoride. Okay, so we also identify the elements there. So the elements, we have magnesium, we also have fluoride. So the word fluoride is coming from fluorine. Okay, so we have magnesium, the symbol is Mg. What's the valence of magnesium? Okay, so from the periodic table, magnesium is in group 2. So the valence is 2. So we write the 2 on top there. Okay, what about fluoride? What is the symbol for fluoride? Okay, the symbol for fluoride is F. Okay, so that is the symbol for fluoride. Okay, so having written the symbol for fluoride, what is its valence? Okay, so where is fluorine? In which group of the periodic table do we have fluorine? Okay, so fluorine is in group 7 of the periodic table, and we know that the elements in group 7, they have a valence which is 1. Okay, so I have a 1 on top there. What is next? Those valences, they will interchange. Okay, then we have Mg, which will go with the valence of fluorine, which is 1. We drop it down. And then fluorine will go with the valence of magnesium, which is 2. Okay. Then, as we have we said for example 1 and example 2, the 1 must be invisible. Then we have Mg, the 1 there disappears, and then F2. So that is the formula for magnesium fluoride, MgF2. Okay, next we go to D. Okay, so D, it's aluminium oxide. Aluminium oxide. Okay, so aluminium oxide, we write the symbol for aluminium, which is Al. Okay, the valence, so aluminium is in group 3, therefore the valence will be 3. You can check on your periodic table there. Then oxygen, the symbol where we are getting oxide, so oxide comes from the word oxygen, the symbol O. What is the valence of oxygen? It's 2. Then these valences, so the valence of oxygen is 2. It is in group 6, and the elements which are in group 6 have the valence 2. Okay, so we have there. Then the valences, they will interchange. Okay, so Al will go with the valence 2 from oxygen. You have a 2 here, and oxygen will go with the valence 3 from aluminium. Okay, now let me make one important point here. There are times when you are supposed to reduce the valences there. It is when you divide through with the smallest valence there. You can divide through with the smallest valence, but you shouldn't get a fraction, a mixed fraction, or just a fraction anywhere. Okay, so here it's possible that we can divide 2, even that side 2, but this side it will give us a mixed fraction. So we do not need to leave a mixed fraction in a chemical formula. So if that is the case, then you do not need to divide by a smallest valence, in this case, which is 2. So therefore, aluminium oxide is written like this, which is Al2O3. Okay, so that is our formula for aluminium oxide. We go to E, our last question. Now we even put one last question, which is F. Okay, so calcium sulfide, you have calcium sulfide. Okay, so the symbol for calcium, we have Ca. The valence, calcium is in group 2, so the valence is 2. Sulfide, the symbol, it is the symbol for sulfur, so sulfide is coming from the word sulfur. Okay, in which group do we have sulfur? Sulfur is in group 6, and the elements in group 6 are the valence 2. Okay, so we have a valence 2 on top there. Then the valences will interchange. Then we have calcium that will go with the valence from sulfide, which is 2, and then we also have sulfur here, which will go with the valence from calcium, which is 2. Okay, now these valences, like I was saying in the previous example, I was saying there are times when you need to divide them to reduce them. Okay, so we can divide by 2, even this side by 2. So 2 into 2, it is 1. 2 into 2 there, it is also 1. And remember, the ones there must be invisible. So we have the formula: calcium, an invisible one, and the sulfide there, an invisible one. So therefore, calcium sulfide, it is CaS. So capital letter C, small letter A, capital letter S. That is calcium sulfide. Okay, the last example that I wanted to give to my listeners, before we go to the last example, I would love to ask you to subscribe to this channel as you are watching these videos, and also invite more of your friends so that they can also benefit from these videos. Okay, so just a subscription, watching of these videos is free. Okay, so the last one that I wanted us to do, F, we can say carbon dioxide. Okay, the other name for carbon dioxide, it is carbon 4 oxide. Okay, so how can we write the chemical formula for carbon dioxide? Just like we have been doing it, we write the symbols first and we assign valences. Okay, so carbon, the symbol, it is capital letter C. What is the valence of carbon? So carbon is in group 4, therefore the valence is 4. Okay, so let's look to our table here. Let's look on our table here. So we said those elements which are in group 4, they have a valence which is 4. So carbon has a valence 4 there. And then dioxide. Okay, so we have oxide there. Let us not be confused where they have said di. We shall see why they are saying dioxide. Okay. Okay, so what is there? It is just oxide, and oxide, it is coming from the word oxygen. Okay, so oxygen, the symbol, it is O. What is the valence of oxygen? Oxygen is in group 6 of the periodic table, and the elements which are in group 6 of the periodic table, they have a valence which is 2. Okay, so we have a 2 here, and then the valences, they will interchange. So we have carbon, we'll go with the valence of oxygen, which is 2, and then we'll have oxygen, that will go with the valence of carbon, which is 4. Okay, here once more, we need to divide it through by 2 so as to reduce the valences there. Okay, so we divide 2. We also divide into 2. So always we divide with the simplest valence there. Okay, the smallest valence there. So 2 into 2, it's 1. So we have carbon 1. And then 2 into 4, it is 2. We have oxygen 2. Okay, then the 1 must be invisible. Then we have C or 2. Okay, so this is the formula for carbon dioxide, which is CO2. So di means 2. No wonder they are saying dioxide, meaning we have 2 oxygen atoms there. No wonder they have used the word dioxide. For this one, carbon 4 oxide, meaning they are telling us that the valence of carbon in carbon dioxide, it is 4. Okay, also you just assign the valence of oxygen, which is 2. No wonder we assigned the valence for carbon, which is 4, just like they have said there, carbon 4 oxide. Okay, thank you for watching this video. Be sure to subscribe to my YouTube channel and invite more of your friends. Next time, I'll make a video for radicals, as in how we write chemical formulas where a radical is involved. So next thing, we are saying radicals. Okay, so for example, we can write a formula to say calcium carbonate. Okay, so calcium carbonate. Okay, so carbonate, it is CO3. So where is this carbonate coming from? It is not coming from the periodic table. Somebody, of course, may say, this is carbon, then there is oxygen. Okay, so carbonate is not from the periodic table, but it is a radical. And so you must know the radicals because they also have their own valences. Okay, so about radicals, there is no use of the periodic table. You just have to know them. You need to find a way, figure out a way of knowing them, and I'll be there to help. So come again with another exciting video. Thank you for your time and stay blessed.